for us tree nuts, we may have all of that equipment on there, and you might spend a couple $1,000s or easily more than that if you wanted all of it. But really what it boils down to get the basic tree height measurement, is you need at least a unit that's going to give you your range, which is your rangefinder, all right, and an angle, which would be your clinometer. Okay, you can get units that combine these two, and then they have greater accuracy. When you do that, then you go up the price chain. But just for getting a basic clinometer, you can get, a lot of us these days are using these Nikon clinometers. These are hard to find. These forestry 440s, I can't find a company that sells them straight out brand new anymore. So, but there's other reasons. There's many reasons why we like to use certain lasers. But these older Nikon versions, you can get them from a certain company that they're refurbished and they work really well. They're just not brand spanking new, okay? But this particular laser, out of the box, is accurate with, they say it was accurate within half a yard, okay? And it does really the same thing as this one that I've had for probably over 10 years, okay? This is a Bushnell model. And this one, though, out of the box, it's accurate to within, they say, plus or minus a yard, okay? You can get the higher-end units, which you could probably get down to an inch or a centimeter, okay, if you're willing to spend that kind of money, and you can get that kind of equipment. But just the basic stuff, you can get a rangefinder from usually anywhere from $150 to $300, and these inclinometers, $100 to $125, and you've got the basic equipment that, if you're really any type of forestry professional, you got to have at least those two if you're thinking of trying to get any kind of accurate height measurements on trees. And really, the measuring your height method isn't that difficult. A lot of people, as you start talking various trigonometry, and their eyes glaze over, okay? But we're not saying you got to memorize sine tables and tangent tables and all that. But you need a scientific calculator, unless you're like Bob, who's got all the sine tables memorized, all right? But and you might need something to keep your measurements. These Right in the Rain books are awesome. If you're like me, you're dropping them all the time in the mud puddles, or you're crossing a creek, and they're waterproof. And these are great. You write with a pencil, it doesn't smear ink. If you get that wet, you can't write with ink. So these are great to have. And if you want to know what the diameter of the tree is, or the circumference of the tree, you got to have a decent D-tape. I like to have them that have ones, that's measured in tenths of a foot on one side and the circumference on the other. Okay, you can get diameter on one side and circumference on the other. You can get them in centimeters, meters, the metric system if you like. I still like doing it the standard way. Okay, but we can easily convert back and forth if you have to. But when you're trying to measure the height of the tree, if you do it the traditional way, you need to get 66 feet away or 100 feet away, whatever. You measure with a tape from where your eye crosses that trunk, and you're ideally on flat ground, and ideally you're measuring a tree like a telephone pole where the top is directly over its base. Okay, and if you have conditions like that, using the traditional method, you're okay. But when you get out in the field, you're rarely, when you go to measure a tree, it's very difficult to get yourself on a level slope where you can actually see the top of the tree. But the traditional way of doing it, you get, let's say, 100 feet away from the tree, you know that tape distance from your eye to where that tree, where your eye is slicing that tree. So you got that tape distance, and then what you do is you take your clinometer, and you, for the most part, eyeball what you think is that top point on that tree. And if that tree is leaning any type of way, if you're not perfectly level, there's lots of things that can go in to make a big error. And we'll have a number of you practice a couple of these different techniques to see which is more consistent and which is possibly not. Okay, so we're going to use the old way a little bit, but mostly we're going to stress to try for you to learn the new. It's called the new way. It's not new. This has been, our surveyors have used it for many years. Okay, it's just, let's say, new for the forestry profession. But all you do is, the key with viewing it, we might call it the ENTS method, Native Tree Society method. All it is two sine triangles. When we do it the traditional way, we're using tangent-based methods which incorporate oftentimes a lot of error, so your measurements aren't repeatable. But when we do it, use the Native Tree Society method, all you're doing is you use this for your distance, and the key is getting the distance from your eye to that top point, the hypotenuse distance. You can't physically run a tape up there. Okay, and when you're getting that hypotenuse distance, now you're using sine triangles, and now you don't have to worry about whether your tree is leaning away from you or towards you, whether you're upslope, downslope, because those planes, they're not overlapping. Okay, they're sitting on top of each other. So to make it basic, first you would get, let's say, a distance to your top point. Okay, and you would get that off your laser. And then you would get an angle to that same top point. So now what you've got is a triangle up to your top point, your hypotenuse distance, and I've got an angle up there. Now that triangle is taken from the bottom portion of that triangle is taken from my eye, and that slices that tree wherever that is. If I'm up a hill and I'm looking down, I might slice that tree 50 feet up from its base. Okay, so that's what we're going to compute. We're computing a triangle from my eye up to the top, and a triangle from my eye down to the bottom. So you get a distance and an angle to the top, and a distance and an angle to the bottom. And as long as that base is below your eye, you're adding those two triangles together. Okay? But if you're looking up the slope and say I wanted to measure a tree that its base was above my eye, you have to remember to subtract that bottom triangle, because if you don't, you're going to greatly overestimate the height of that tree. You have to remember in relation to where you're sitting. Okay? And if you read the straight angle off, you can get minus or plus angle on your clinometer and do it that way. Some like to do it that way. I personally just like to remember if I'm below slope, if I'm below the base of the tree looking, let's say, up the hill, then I have to subtract the bottom triangle, because what you'd be doing is projecting a bottom triangle down into the earth somewhere, and you don't want that. You have to remember to subtract that bottom measurement. So ideally, you have a distance and an angle to the top, and a distance and an angle to the base. And then all you do is your basic trig. So you have a distance, my eye to the top, and you multiply that times the sine of that angle to the top. And that's your top height triangle. And you do the same thing for the bottom. You have a distance to the base, mid-slope base, okay, and then the angle to that mid-slope base. So you have these two height triangles that you're going to add together. And that's really all the method is. The hard part, though, is depending on how complex your crown is and where you're standing, you may not be able to see that real top sprig. But whatever you measure with this, you're often, with practice, we've done it with folks who've never used the equipment before. First time you pick it up, you know, and we're not really trying to be extremely accurate, but first time picking it up, folks are often within 5 feet of each other. Whereas if you use the traditional forestry method, I might be 20 feet off, someone might be 5 feet off, someone else might be 40 feet off. This way is much more repeatable, and the more accurate equipment you work with, the finer you can adjust those errors down to. Before we do any measurements, one thing you want to do, if you do get one of these rangefinders, especially the lower grade ones, the first thing I do, if you buy one like this one years ago, it says accurate to within plus or minus 1 yard. Yes?
Quick question. Plus or minus 1 yard with compared to what?
Whatever the true distance would be. So if I've
made... Is that 1 yard and 1,000 yards? Is that 1 yard and 100 feet?
1 yard regardless.
Yeah.
Regardless.
From me to you or from me to
Except, let me interject one thing.
Okay.
Some of the models lose accuracy at a greater distance. Others maintain, I don't know, Steve might understand that a lot better than I, but others maintain that same error rate at longer distances versus short. For instance, the True Pulse here, the LTI product, it's plus or minus about a half a foot for distances well out to at least 100 yards.
Yeah, most of the lasers for the distances that you'll be measuring trees at, the accuracy isn't going to vary over distance. You may be thinking of other technologies like ultrasonic, sound wave technology. those accuracies can vary the farther distance you
Depending
go.
upon your distance.
But for
That's
lasers,
why I
for
wanted
all
to know
the
something.
for all the short range type work that you'll be measuring trees at, the accuracy is constant.
Great, nice. Thank you.
Yeah, it's just a matter, if it says it's plus or minus a yard, get a tape out and measure to your target. Ideally you want a nice reflective target, okay? I generally use a tree because that's what I'm going to be using in the field. Get out in an open area, measure, take your tape and just stretch it out 100 feet, 100 yards, and see what your laser does at each one of those points. If the tape says 100 feet and your laser is shooting 102 feet, and you're within the tolerance if it says plus or minus 1 yard, okay? But if you went to 150 feet, is your laser now, is it still like 2 or so feet off, or is it now 2 feet short? So you need to kind of see what your laser does. If it's consistently over at a certain, range, then you might be able to compensate for it. This one, mine shoots consistently almost 2 feet long. So I subtract that when I'm doing my measurements. Some lasers are consistently short. Some, they're plus or minus. So you don't have to worry about any of that, But it all depends. You just have to learn to see what your unit does before you get out there in the field. Okay?
And by the way, to add to that, you continue checking on the calibration of your instruments. I do it compulsively, as you might guess. But realistically, every few months, you ought to do a check on the calibration of your instruments. They don't stay calibrated forever. And in the case of clinometers, if it's a built-in unit, the tilt sensor often has a recalibration method in the instrument. So you periodically go through and recalibrate the tilt sensor. And in the case of this one, where I can shoot angles, vertical angles in the vertical plane, or also angles in the horizontal plane, azimuth, there's a separate routine for each. And you really have to be very careful to recalibrate when you have a horizontal angle, because that's usually based upon a compass, magnetic interference with this instrument. You get it around a magnetic field, and that compass is out. And I'll do that, and I'll think, what on earth? I mean, north is that way, not that way. And I'll realize that I was in some sort of magnetic field, so I'll simply recalibrate the instrument, and then you're down to whatever level of accuracy it's
Before we get into measuring, I want to introduce some people are here that really know how to know the method really well, okay? And a lot of them are I'll have you see lasers hanging around their neck, okay? I've got 2 extra lasers in the box with clinometers. If you don't have one, I'd encourage you to pick one up and kind of, that's yours for the weekend, or trade it off with somebody else. Or go to one of the folks that have one of these around their neck, and they'll get you familiar with the method. But first, let's see, as we go around, everybody knows Bob, okay? Ed Frank here, he's the webmaster for the Native Tree Society. He's doing some video along the way, just ignore the video, okay? But in terms of the method, he'll be able to explain the method to you as well. Scott Wade, Scott's the Pennsylvania Big Tree Coordinator. Really is responsible for that Big Tree list book that's put out every year on Pennsylvania big trees. Let's see, Randy Brown is our Ohio Native Tree Society rep, and Scott Wade is another one of our ents from Pennsylvania.
That's Carl Harding.
You
always do it. You always do it.
Usually it's him and somebody else. So that's great.
He's much better looking.
Scott, Carl and Scott. Yeah, that's great. You got to watch me. The danger is when I do that between trees. So, yeah, I'm sorry, Carl. Carl Harding. He's our one of our Pennsylvania Native Tree Society reps. Carl and a number of other park volunteers have been helping me out a lot over the years measuring trees. Carl's very good as well. Turner Sharp, he's the West Virginia Big Tree Coordinator, and exploring a lot of sites down there. And Steve Hallow is a recent addition to Native Tree Society, and he's been stealing a lot of our tall tree records here from Cook Forest. He's doing a lot of exploration down in southwestern Pennsylvania. Some of the that tall tree data sheet that I gave you doesn't have a lot of his recent additions in there. He's found some really exceptional sites down south in southwestern Pennsylvania and starting to put the Pittsburgh area, Ohio Pile area, let's say, on the map. So a lot of areas we just don't have a lot of exploration in. Northwestern PA, southeastern Pennsylvania, we got a lot of stuff, but not a whole lot for northeastern Pennsylvania. We're starting to get a good set down there for southwestern PA. And this is Steve Colburn. He's the really North American sales rep for Laser Technology Incorporated. He's got a number of nice lasers for us to use. This is like baby steps, okay, to start off with. And you can get into the really nice equipment that you can really get some serious accurate measurement for. And so, need any help? Those are the folks that'll be able to really help you to explain the method that we're going through here. So, how do you want to go from here, Bob?
Well, one of the things I thought of, again, thanks,
Yep.
Dale. And Dale and I were out yesterday, and we were looking at different trees. I said, can you choose a tree that's going to give us some real challenges so that whatever I was blabbing about in there, you could illustrate out here. And we chose this beautiful person over here, this white pine. It goes into a double real close to the top. It's got a kind of a lean to it, a slight lean. So that presents us with the non-vertically oriented telephone pole in a level parking lot model. It is a violated staff. In addition, what we really want to see is how accurate we can get. And let's start off by doing things that people traditionally have done, measuring trees. From surveyors, anybody that's been a surveyor, is a surveyor, or has been involved in surveying knows that one of the standard units of length was a chain. Anybody know how long a chain was as a measure? 66 feet. Now, some of the early clinometers that were set up to allow you to look up and actually get a number that represented the height of the tree based the baseline on 66 feet. And you either went 66 feet back or a multiple thereof. And I have been involved in discussions with professionals who thought you could get back 66 feet from a tree, use that as the baseline, and get an accurate height for the tree. So let's start out and see just how well that works. Now I'm going to take my trusty True Pulse and figure out where 66 feet away is. And then let's start measuring the height of that tree using the traditional method and see what kind of numbers we come up with. Feet is right here. So we could, I'll put down a marker at 60 feet here. Oh, okay, good enough.
Nice job, Scott.
There's one. Now I'll go over here and I'll get another 66 so we can not all be...
You're into old growth there, you say?
Yeah, okay.
Just rough.
Okay. We were getting from 66 feet, we were getting anywhere from like 141 to 168.
Okay, 168 versus roughly 120 feet. That's a 48-foot area. Now, doesn't that tells us, that should tell us we can't measure that tree accurately from such a close distance. Reason why? What's the reason?
The angle, sharp angle?
No, not the angle. If we could see the top, that wouldn't make a difference. Angle doesn't affect it. It's the fact that we're not shooting the same target. We're shooting limbs that are sticking out, and that's what it looks like. And this is a point that I see over and over and over happen. It isn't obvious where the top of that tree is. We will eventually see it. We'll see it down to the sprig, but we can't see it from here. Now let's see what kind of error we run if we get 100 feet out, because 100 feet is the normal tangent-based baseline to use, particularly with clinometers that have the slope scale where you can, if you get 100 feet back and look up and read the right scale, presumably you read the height of the tree. No math, just choose a number. Let's see from 100 feet.
Okay, what we're going to do now is we're going to estimate the diameter of the trunk from a distance, okay? And where that comes into play is, you know, down low, we can run a tape there, okay? But if we want to estimate the diameter of a distance as we go up that trunk, unless you're climbing it, you're not going to know for sure, okay? Or, like Bob said, let's say it's across the river, you can see it, but you know you're not going to be able to make it, or you know, a ravine or something like that, where you can still get pretty close, accurate estimating diameters at a distance. And you can do that with this instrument. The one I have sitting up here, this is a Macroscope 25, and what you have inside here is a scale, okay? And so what you do is we know the distance, okay, from our lasers from this point to the tree, okay? And then what we do is, let's say the left side of the scale is the left side of the tree. And then the right side of the scale is intersected by the right side of the tree. So you read that scale, okay? Let's say you come up with a number like 1.5, okay? Then what you would do is you would take that reticle number from your, let's say it was 1.5, and you'd multiply that to your distance to the target. And then you divide that by a factor that per se comes with the instrument. For this one, when it comes out of the box, they tell you that the factor, reticle factor, is binocular factor is 75. Bob and I just tweaked this a little bit yesterday and got it a little bit different. That's kind of like knowing your instrument. So when you get your laser out of the box, you want to know what your laser does along a set range. When these come out of, when this unit comes out of the box, it's not necessarily going to be right at 75. And the closer that you can compute your reticle factor, the closer you are going to be on your measurements, okay? But for this demonstration, what we did though beforehand is we measure, when you look through these instruments, you're going to see a little tiny white thumbtack on a tree. That's going to be where you want to line up the scale. Ideally, you want the scale to go right through that thumbtack, and left side of the scale, let's say, is the left side of the tree, and wherever that tree intersects your right side of the scale is going to give you your number. Okay. The better tripod you have, the smoother moving tripod you have, the easier it is to get yourself set up. If you've got a low grade tripod like I do, you almost have to tap the tripod. It takes forever to get it set right. If you have a better one like Bob does, the higher grade ones, it's just real smooth, and you can put it right on. It's hard to get it set up with mine. Better tripods, it's a little easier. Then you just look through it, and you're matching up the left side of your scale with the left side of the tree, and then you look to the other side of your scale. Wherever that tree intersects, you can get a number. On my scale, on the top I've got millimeters, on the bottom it's in inches. You can use either one, okay? But Off of this, I'd suggest to just read the top one. The top scale seems to be a little bit easier to read, unless you want to read it in 16ths, 18ths, or whatever. Okay, I'd read the top scale, and it doesn't. The millimeters, we don't have to worry about converting that because we're just using it as a scale. Okay, so take a look through here. I encourage you to take a look through here, see what you get for your numbers. If you don't bump it, it's actually pretty close. So you can kind of see where I have it lined up. If we were to pick this up and do it again from another place, we could, it'll take a little while to get it set up. But what I did beforehand is I got the diameter of that tree at that little tack. Okay. Now remember, trees aren't perfect circles. So from this angle, the diameter of that tree, I know what it's supposed to be in my head. We used a caliper. There's a big caliper down there that we used. Now, if we were to go over to this side, this extreme angle, and measured that diameter at this angle, it might be 3 inches different. Okay, so you have to remember when you're doing that, what your point of view is, because remember, trees could be ovals, it could be almost, rectangular kind of in shape.
Average it out.
You could, but from what we're trying to, I wouldn't.
I know I did. I figure out
Class, either the as-built records are off, or they've shrunk so much the diameter is changed.
Number one.
That'll be the diameter in inches, bottom.
Okay, but the scale,
The scale is,
on the right edge, but the left edge.
You
you want to try to match up both edges.
Yeah, it just needs to move. The whole thing needs to move.
So you just use this thumb button to expand and contract the LEDs. Go ahead and
Oh, I see.
push it.
On the right-hand side, it's lined up.
Right. Go ahead and use your and just expand and contract. I mean, you might have to move the instrument a little bit to get it where it's just right.
Because the left-hand scale,
Yeah, they'll both kind of go simultaneously. So you might need to swivel the instrument to get it just on. But you just get both of your eyes touching the edge of the tree.
If it's got a big swell like that,